session was useful for you. Now, moving on to next session for the day. Our next workshop is Digital Identity and Security for Blockchain. This workshop has been conceptualized with a bid to acquaint the delegates with the use cases of decentralized identities and how they are allowing systems to emulate the trust we have in physical credentials in a digital context. To conduct this workshop, I would like to invite Vinayak Godse, Senior Vice President, Data Security Council of India, and Vishwas Bhushan, co-founder Hypermine. Welcome, Vinayak and Vishwas. Over to you.
Yeah. Thank you, Amita, and welcome all the participants of NATC to drill into the digital identity and security of for blockchain. So this is an important session which probably reflects on what the evaluation that we are seeing at this point of time, especially in the case of Web 3.0 discussion or the blockchain and more importantly metaverse discussion. So when you look at the digital identity, basically, so we had been seeing, if you just look back some years back, it will be like online authentication was a key reason. Then e-signatures has come into the picture. But contemporary, what if you look at, it's largely we are talking about because of the pandemic, also the age of where you are trying to bring your own identity to the enterprises. Basically, you are talking about identity proofing. We are talking about delegation of identity, but more the discussion that we do in terms of Web 2.0, a lot of issues and challenges that had been now discussed in the context of the way the Web 2.0 has been evolved. Basically, so it has really helped to aggregate entire ecosystem in a way that certain organization may probably or had been discussed, like certain organization controls the significant amount of data. So the data that has been collected by those organizations and the kind of big global fortune has been created out of it had been challenged from the context that the end citizen or end customer data which is being used by this platform to build the big fortunes, basically. So entire identity ecosystem nowadays going to challenge some of those existing concept of the Web 2.0, and these concepts are now increasingly being challenged, especially the emergence of Web 3.0. And if you look at the Web 2.0 means, what is the Internet of Information that we talk about? When we talk about Web 3.0, we are talking largely content economy, and we are talking about Internet of content, basically. And then nowadays we are seeing more like a network of blockchain platforms, which are in many blockchain platforms are now engaging, interacting, interfacing with each other. But increasingly the world is going for the Internet of value. So from the World Wide Web to World Wide Ledger, where digital asset, ledger, smart contract, all these protocols that are coming in the context of the Web 3.0 and the entire economy, parallel economy that basically in place, which is probably is evolving. There are a lot of discussion, a lot of concept, a lot of ideas, basically, which needs very in-depth kind of deliberation, basically. When you decentralize thing, if somebody is not controlling your identity, somebody is not provisioning, basically provisioning you to certain application, or provision you to get the resources from the centralized computing system, how does an ecosystem evolves, basically, how that really goes in terms of the way the architectures are formed, basically. So those are the discussion that we'll be doing as a part of this particular detailed workshop. And for that we have Vishwa here, who is a founder of Hypermine, and which is one of the pioneering company in India which has been working in the self-sovereign identity ecosystem and had been getting quite a good traction both here in Indian market and global market as well. So when we are looking towards the programmable economy and society, and we are looking towards more privacy aware and privacy enabled kind of a ecosystem, in that case the decentralized identity ecosystem becomes very important. In that case, basically, a way we manage our identity and way we allow organizations to work with our identity matters a lot. And there are a lot of architectural engineering developments which are going on at this point of time, and we will like to go through that with Vishwa being here. So how we devise this particular workshop is Vishwa will take us through some of this concept of the decentralized identity with his presentation, and towards the end there will be also demo as well. But what I like all the participants joining here is please put your messages here on the chat window which is available for you. So in between and towards the end, basically we like to go across all of those questions and those comments that you put here basically. So with this, I think I will request Vishwa now walk us through the through this entire decentralized identity and how entire ecosystem around that is changing and how it is enabling this Web 3.0, and nowadays people are talking about Web 5.0 as well. So how some of these ideas, some of these architecture engineering evaluations are really enabling entire this ecosystem. So walk us through that, and then in the course of the discussion, we'll like to hear from all the participants here, and we'll take your inputs and points to carry this discussion in more dialogue based basically. So over to you, Vishwa.
Thank you, Vinayak. Let me share my screen. Uh, can you guys see my screen? Is it? I hope you can see my screen now. Hello, can you guys hear me? Okay, so we'll start the presentation, and I want to start today with this term digital trust that we are talking uh, in the space, right? Like government is pushing digitalization, and everybody is talking about digital. We started with payment, solving the payment problems, uh, and digitalizing it, and and then we are digitalizing almost everything in this space, right? Like we digitalized the Aadhaar, we digitalized PAN card, all sort of documents we are trying to digitalize. Uh, but it would be fair to say that it's very hard to achieve, uh, and we have kind of failed miserably. Uh, and it's sort of, and the reason for this is that digital trust that we are talking, this trust looks like one-sided trust. As in, if you think from the user's perspective, if I use a particular system, uh, I there is an intrinsic trust already being established, although users don't know. And that trust is that the service provider is going to secure my data and it will protect my privacy, right? But we have been seeing services getting hacked. They share our personal data with other services, sometimes without even taking our consent. And then I'm sure you guys all can relate that you every single day you get calls from unwanted service provider which you would have never subscribed to, like, right? Like you must be getting credit card calls from a company which you don't even know and which you have not intended to even try it out. So how come they are getting your data? And of course email address is one of the personal data. So how they are getting, or your phone number, right? So how they are getting all this information? So definitely the informations are being shared across this applications, and and it's kind of misused, right? They are all interlinked, and these apps are creating basically your digital portfolio, that what kind of person you are and all sort of things, right? So 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 what is happening here is basically uh, you are kind of trusting the services, but it's being your trust is being betrayed, so if I put it in that way. And I think that is the reason of all this cryptocurrency evolution came, where they say that, hey, trust is not really a problem, not really a solution, but it's actually a problem. And then we started talking about trustlessness instead of trust. So So which is why I feel that it is one sided. We as a user, we are not really uh, services are not really caring about our intent. And there are two things which is very important to establish this digital trust. Is one is identity, and other one is data, right? Identity, because we start, that's the starting point. The moment you open your laptop, you start with that identity thing. Whether you log in or not, there is identity always involved, and we will talk about identity in the context of internet versus identity in the context of real world shortly. And then you have data, like how are you sharing your data, how your, I mean, we all know that we end up sharing more information than what is required. So for example, if a service is a, if a service just need your address, you don't have any way to share only the address part of Aadhaar card. You end up sharing everything: address, name, phone number, whatever, everything sharing, because there is technically there is no way to digitally share that. We have, if we have to share one piece of information, although one piece of information is required, but we end up sharing all of it. And we do it multiple times. Every time we go to a new bank, we have to do a new like KYC. I am the same person, but I'm doing KYC over and over a time, right? So these are the two pillars that we will discuss today. And but before I go into that, you already know, like I am co-founder of Hypermine. I head engineering team here, and I'm really interested to solve privacy issues, and I'm strong advocate of user-centric systems. So so let's start with the identity part of it, right? So if we think about deeply, like what is identity on internet, we don't use our Aadhaar card to log into a system or access any kind of or use any physical identity to access a system. So our identity on internet is nothing but identifiers, right? So for example, your email, phone numbers, Facebook ID, your usernames, all these are identifiers that you use on the internet to identify yourself. They're not your real identity. These are the identifiers which is issued by many service provider, where whichever service provider that you use, be it a Gmail or be it a Airtel or any telecom operator, and you use this identifier to access systems all over the internet. Now, what is interesting thing about these identifiers are that they have existence on the internet. Like if somebody revokes, you know, these identifiers, you basically lose the access to all of the applications where you would have, you know, accessed it. So, for example, if you would have used your phone number to log into ABC Bank, and if telecom operators by whatever ways, like by whatever reason, they decide to revoke the access of phone number, you literally lose access to all of the banks that you would have used. So it is that critical. That is what I wanted to stretch it out. That existence, these identifiers are really important for us, uh, for to define our existence on the internet. And the problem with these identifiers are basically you don't really control your identity, right? Identity or identifiers, I'm trying to use this both of terms interchangeably. So in the context of internet, I believe that identity is identifier. So when I say identity in the context of internet, it's basically I'm talking about identifiers. So you don't really own this identity. You would argue that how come I don't own this identity? I have the password interlinked with it, so I definitely own it. Not really, right? If 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 I am the identity provider, and if I decide to delete, just go and delete your record from my database, you suddenly lose access to all the applications where you would have used that identity. So you don't really uh, own that identifier. And then these identifiers are interlinked among the services, which is a great problem for privacies, right? The way uh, people define this identifier, that you can control it using passwords, and we all are aware about security flaws with the passwords. uh, we keep on forgetting, so we end up using same password everywhere, and we know the consequences of that. And of course it's difficult to manage because there are hundreds of them. every day, as the as we are growing, the digital apps and everything is growing at the same pace. So every new app, a new identifiers that we have to create and manage ourselves. And the most important part which I wanted to focus here is, you cannot deassociate yourself with these platforms. Why it is important to deassociate is because, imagine that you would have used a phone number to uh, you just wanted to try out a website, and there is a OTP login, and you would have used your phone number to log into the website, and now you don't like that website. So you don't want to associate yourself, because you probably know that these people might be sharing your phone number to someone else. The problem is, there is no way you can say that, hey, I don't want to have this relationship with you anymore, because you cannot create as many as phone numbers as you want, right? There is a limitations. Creating phone numbers are expensive, and you are using the same phone number in your to log into your important one of the important application, which is a bank. So so you basically stuck. They keep calling you, and so for example, it happened with me that I completely closed all of my accounts with the Hathaway, and Hathaway guys kept calling me even after 3 years, that please use my service. So so there is no way that I can stop this, no matter how many numbers of Hathaway I can block. I'm literally taking this name because I'm really pissed off with them. So yeah, so there is no way that I can associate myself with them, because I have used the same phone number to access my bank account. So this is the current situation that we have with these internet identifiers. Guys, I'm not looking at the questions. If you are asking, then I'm really not looking at it. So I'll pause for some times in between, and then take up the questions. So this is the current situation of internet identifier that we have, where uh, all your data and identity is being controlled by these apps, and they are in the center of the ecosystem. You don't have any ownership of your own data. Anything, like be it your email address, be it your healthcare records, everything has been controlled by these apps or companies, who are having your data. uh, Before we jump into the decentralized part of it, and why do we need that, I just wanted to uh, quickly go through how this identifier actually evolved. you know how these identifier systems uh, have been evolved. I'm sure that many of you will relate to this. We started with a silo model, where we had like so many service providers, and then with each service provider we started creating user IDs and passwords. So each service provider will issue us one key pair, username and password, right? For the service provider, it is expensive in the sense that they want to focus on their business, but because authentication itself is a complex thing, so they end up spending more time in dealing with the security part of, and implementation part of authentication, rather than their business itself. So it's expensive for the services to do. It's bad for usability, we all agree on that, because you have so many passwords and to manage, and hence it's not secure, because you end up using one password in all of these accounts, and if one get hacked, so you basically compromising all of this, all of the services that you would have used. And of course your data is spread across all of these service providers, so, and you don't know from where it is getting leaked. Then we move towards something called federated model, where we outsource the authentication. As in, if a user wants to access a service, the service provider said that, hey, I want to delegate this responsibility to someone who is very experienced in this field, and these guys are called identity provider. So they outsource the responsibility to identity provider. Now identity provider gives them one ID, and you use this one ID to log into any of the application which you want. The problem here is clear, that it's centralized. Although they solved the UX problem of the user, but then this control, the access is being controlled by one system, right? And if that one system fails, you basically lose access to all of these systems. Recently we had a Facebook outage, right? So imagine that a user who would have used the Facebook login to access some of the websites, so they would have definitely lost the, you know, access to that, all those apps. Security and privacy depends on that one system, how they implement. Although we agree that these people are really experienced, so they would but then again the question of trust comes, like, we are trusting them to not do anything bad with our data, but we have a cases of Cambridge Analytics and whatnot, right? So, and then to have a scalability issue. So imagine that one of these service provider grows millions of subscribers, then the identity provider has to cope up with, you know, that growth. So 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 that's the scalability issues that these identity providers would definitely get. So and this is true in the context of Aadhaar also, right? Like every time you use a digital Aadhaar system to access a service, the service provider have to make a call request to the Aadhaar system, hey, please verify this, whether this Aadhaar ID is correct or not. So issuance is one time, but verification is happening exponentially, right? So that's the scalability problem that we have with this kind of model.
So Vishwas, we can little bit stay here and discuss on the from the context of the privacy. There's one comment I just see on the privacy. So there are some expectation of privacy which has recently because of GDPR evolved, right? So which talked about need for data deletion, right? Data eraser actually, right?
Mhm.
And then also the better control of a subject on data basically. So subject access requirement as well actually, right?
Mhm.
So these concept and then current way of managing identity. Can you just reflect on the privacy, the principles of privacy and the content of the different expectations of privacy and how that are very closely knit with the challenges that we see in the Web 2?
Yeah. So GDPR is a very good point to brought it up. Uh, Personally, for me, GDPR is not really solving a problem. Like, it is definitely a rules that you have to apply. That has been applied, but it's not a technical solutions of the same the problem that we are talking, privacy issues. Uh, of course, there is a law like, okay, if you do something wrong with it, then you have like you have somebody who can, you know, can come and caught you catch you. But I don't believe that that's a technical solution to this problem. And after reading about my decentralized identifier, I realized that, hey, this problem can be technically solved and can be stopped.
Yeah, so one of the things that you talked about is your ability to deassociate yourself from any player, right? And that's the requirement. I know कि GDPR always, any such law will always come as a regulation, right? And
Yeah.
then you somebody like you has to find solution, technical solution for that basically. So so there is definitely some expectation which came, and this expectation is coming all across the globe. Not only GDPR but many others also following that suit basically, which talks about one of the key requirement or key right that data subject enjoys is to disassociate or its ability to delete the data from the particular player basically. uh, and in the current context it's very difficult to make sure
Yes.
that the data is deleted and even verify that basically.
Yes.
Whereas the discussion that we'll be doing would be discussing about the technical solutions which are emerging basically. So that's the context that I just wanted to set up before we go to the next stage.
Yeah. I wanted to add one more point in the context of deleting a data. So uh, one way is to, okay, yes, you actually delete that, which is not happening from the service
Yeah.
provider end. But from the user end, what we can do is imagine that if I can create so many identifier, for example, emails is free, right? So I can create temporary emails also. And imagine that I just wanted to try it out that system, so I just created a temporary email and use it, and now I don't no longer even looking at that email. So it's also a sort of deassociation, that because I don't have access to that email address. So even if they are trying to reach me out, I don't mind because that's not,
Mhm.
yeah, it's
Yeah.
not disturbing me.
Yeah, and
So
that siloed way of managing identity led to this federation, but the federation is creating a lot of issue in terms
yeah,
of centralization, single point of failure, and more importantly, then aggregation of all that information to select players, basically, right? So
Mm-hmm.
that while you solve one problem, but you create another big
Another
problem
problem.
as the outcome of that, actually.
Yes.
Yeah.
Yeah. So why do we need decentralized? We need to decentralize. I mean, to some extent, we all agree that we have to decentralize. But to what extent is the question? And I think it depends on the business also. That to what extent you want to decentralize. For example, the blockchain itself, right? You don't want to use blockchain everywhere, and wherever you have a trust issue involved, only at that module you will be using the blockchain, not everywhere, right? So so why do we have to use a new sort of, why are we even talking about that? Because we want to take ownership of our identity on the internet, or identifier, and I want to claim my existence on the internet. So because imagine that I'm a very good content creator having millions of subscribers on YouTube, and if YouTube decide to block my account, I won't be able to prove that I was a good content creator. So claiming that existence on the internet is important. And of course, internet is now become the de facto way of communication, so it has to be secured, and you know and my privacy needs to be protected. So basically we want to get away from this current model of identity systems, and we want to reach here, like self sovereign identity, where I keep my data and I decide which application I want to use, and then I decide where, to what extent I want to share my data, and when I want to deassociate finally from that application. So this is where things are moving in the identity space, like getting from this federated model to decentralized identity model. So now, in attempt to reach there, W3 Foundation there was a proposal in W3 Foundation about the decentralized identifiers. Like we can have uh, identifier which can be controlled by user. So that proposal was made, and the good part is it is being now accepted by the community last month only. So it's a very great you know uh, progress in that field. So let's talk about decentralized identifier, DIDs. So DID is it might be a very fancy term, but technically it is nothing but an identifier which has certain properties, like it's unique, globally available, and we all know the uh, the importance of being able to globally available. For example, if you are using your phone number in India and trying to access your bank account, and if that telecom operator does not operate in US, you are not able to access the account, right? So which is why it is very important for these identifiers to be globally available. At least email solves that problem. Cryptographically verifiable, like any activity that I do with this identifier, it has to be verified, right? So uh, I'll talk about certain properties of like how exactly that it looks, how is the data structure of this identifier. So it has this three part. In this example you can see the first part is the DID, this word is fixed. The second part is the method is something like is specific to a use case. For example, if your use case is healthcare, and if let's say mm, I don't know who is the in India who is the like governing body of healthcare system. I'm
That is
forgetting.
NHA, right? National Health Authority.
Ah, NHI.
Yeah.
So if they
Yeah.
decide to have a method, they can have that method here,
Mm.
and then they can decide what cryptography that they want to use for unique ID that they want to attach, right? So so that is what in context of airlines it would be DGCI, I would say. So they can define. So this is the structure of that UUID, that identifier, but it is not exactly GUID because it has more part of like it gets resolved into a document, which I will explain in the next part. And this DID are linked with cryptographic key pairs, not just one. You can attach as many as key pair as you want. I'll just quickly show you like how exactly that you these key pairs attached and linked. But for now, just understand that this is not just one id. This id gets resolved into something. You can actually think it as a uri instead of an id. And as I said, that spec is now officially accepted by the w3c, so that's a good news for us.
So, one certainly area where we'll reflect on, which one may not be here, but in this context, we have to check the government issued identity like Aadhaar, right? So we will
Mhm.
certainly visit that because if this is a globally available kind of a schema of identity, basically. So what would happen if in the context where we are, as a country has adopted UID, basically? We'll
Yes.
probably reflect on that during the course of discussion.
Yes, of course. That part I will come when we talk about the verifiable credential
Sure.
thing. Yeah. So certain properties like decentralized, it has to be stored on the decentralized ledger so that nobody can go and just simply delete it. The ownership can be proved using cryptographic key pairs, and of course, you know that private keys are, can be like only users have this private key. Nobody else has. So nobody else can prove the ownership of the same identifier. Then pretty cheap to manage in the blockchain. Although I know that many people would argue on that, but after evolution of proof of stake network and other private blockchains are coming up, so it's getting cheaper. uh, s- Secure and encrypted communication you can do. So if you look at the property of any identifier, what are the properties of this identifier is, so for example, email address, what can I do with the email address? It can be used to uniquely identify me. It can be used to send me some messages. All these things can be, you can do with the did as well. Like, because it's a unique, so unique identifier is anyway there. Second, you can use the did to send a message, because you know that did is linked with a key pair, so I can use that public key to communicate, encrypt some message and send it to you, and then you can decrypt. So secure communications can be happen using these dids. And then the last point is it can be linked with any credentials, which I will come after sometimes when we talk about the verifiable credential part. So here is the flow that you would see now, like that the user, if a user wants to access a service provider, it does not go there and fill some registration form and gets issued a identifier. Not like that. Here what will happen, that user will first create a did on the blockchain and then use that did to access a service. So it's a little bit of change in the flow. Like the starting point is user will have did already before even trying to access a service. That's the difference. So there is a concept of did document comes into picture. I was saying, right, that dids are uris which gets resolved into something. So that something is nothing but a document, basically a json structure, where you keep all the public keys. And that's that this pair, the did and this this is did document, you can just visualize as a key value pair. So that value, the did document exists on the blockchain. In the demo you will see that how it exactly exists. But but yeah, so that document is basically a metadata related to that did. So you can have as many as public keys, and those public keys will be logged into this document and stored on the blockchain. The private key, of course, be private and kept in your the device that you hold. So it looks something like this. So for example, if this is a did, the did document, this is a minimal looking did document which explains certain things. First is the context, that it is of type did. Then who is going to control this did? So in this case, the user uh, who is having the access of this document is going to control the did. Actually, did you can give control to someone else. For example, if a newborn kid is trying to create a did, then of course his controller will be his father. So although the did will be in his for him, but then the controller will be his father. Like using his father's public key, he should be private key, he should be, the DID document should be able to access. So which is why there is a concept of controller, and you can have multiple controllers like your father, mother, as an example. uh, and then you have a verification method part of it, where you actually store the public key depending on what type of cryptography that you are using. It supports a lot of cryptography, uh, ED 25519, ECDSA, RSA, all these things that we normally use. It supports all of them, or at least most of them. And then you can have actually your public key here, so that whoever is trying to, let's say if I want to communicate with you, I'll just query your DID on the blockchain, get this DID document, find this public key, and send message to you. Okay. So that's the DID part. Like, in short, it's an URI or identifier which is stored on the blockchain. The private key resides with you. The DID and the DID document sits on the blockchain. What about the data part? So that's how you will create the identity. So like you yourself is creating the identity, you yourself is controlling the identity. What about the data? How can I share data with these services? How can I share only required data with these services? I just want to share one attribute of my credential with these services. How can I do that? So for that, there is a spec which they have mentioned. It's called Verifiable Credential Data Model, which is nothing but a digital representation of data.
Which were one or two questions I want to take it from here, basically. So, one question somebody has asked, and you can just go back to the slides. One question somebody has asked about the what is different between GUID and DID, basically,
Yeah,
and what is the difference? And second, I think question is on how SP will validate DID, basically. These are two questions, and I will have one question which I'll ask.
yeah, sure. So the first part is uh, it's different than UUID, because here it's not actually a UID. It's actually a URI which gets resolved into a document. So it resolved into basically a metadata. Whereas in case of identifier, like any identifier, it's just an ID, which definitely is used to identify a row or a record in the database. But then here it gets resolved into a metadata which contains your cryptographic elements and your purpose, like what this DID are going to use for. Is it you going to use for authentication? Is it going to use for assertion? There are many other purposes. This is the minimalistic thing. What was the second question?
Second question was how SP validate the DID.
Yes. So the service provider basically, so so if I am a user, I have this DID, I go to the service provider, and it, and service provider provides me a challenge. I use this DID, my private key, to sign that challenge, and then send the signature to the service provider. The service provider sees that it's coming from this DID. It looks into the blockchain, fetch this DID document, fetch the public key associated with this document, and verifies my signature.
Mhm.
And that's how. So no personal data is being shared in these interactions. Just like you know, if you would have used MetaMask wallet, then how that you do with accessing any application. So it's just a digital signature verification, nothing else. Yes, Vinayak.
And another, so you talked about this control, and this is very important to reflect for all the participants here because many regulation, including GDPR, right, and there are some COPA regulation as well in US basically, which talked about so because the children are coming online, right, and even now because of pandemic, almost now children at the age of 3 and 4 have been coming online basically, and there have been a lot of compliance which is coming in terms of how to bring parents uh,
Yeah.
in the transaction where you would like to deliver systems and services and applications to children basically, right? Also,
Mhm.
this controller scheme is largely probably helping you with addressing that kind of requirements coming from the regulation, right?
Yes, yes. So one more thing I want to highlight here about this controller is, in fact, for the DID also, is DID is not just for the human beings. It also can be given to a file document. And
Yeah.
imagine it's given to a file document where you have like three controllers, and three of these guys can access that DID, sorry, that file document, the document, right? So it can be
Mhm.
used for that purpose as well.
So, which
So
for
definitely,
audit purpose, there's another question on audit. So, for audit purpose, like how do we audit who or which systems read DID? At the end of the day, in enterprise ecosystem, you need to perform audit basically, right? Who has done what and all these things, right? So how do you do that actually? Yeah.
yeah. So or your, if you're talking about activities that you do, so you link that activity, all those your activities. So I don't know which example that you're giving. Let's take a social media examples. My
Yeah.
activities are I like, I post, I comment. Let's say.
Mhm.
So all these three activities will be linked to this DID. Now the
Okay.
question would be how this DID is, the DID is not really referring to my like personal thing, like how I am, like, right? So how would you identify that who is actually doing this these three activities is basically with the concept of verifiable credential, which I'm going to talk next. So just keep that
Mhm.
question till there.
Oh, sure, sure, sure. Um, please go ahead.
Yeah, sure. So yeah, I was talking about this verifiable credential thing, and this is what will answer your question. Like, so what is verifiable credential is basically any data which you want to represent digitally can be represented in the form of a verifiable credential. Your Aadhaar card can be represented in a verifiable credential, and the property of verifiable credential is basically it's a private document, so it is only kept with you always, and this is tamper proof. Like you can use this verifiable credential to prove certain facts about you. For example, if I have a verifiable credentials of email address, I can prove someone that I own this email address. If I have a verifiable credential of any of the data, so for example all of the Aadhaar, imagine that Aadhaar ID is in the form of a verifiable credential, then I will be used to I will be using that document or credential to prove all of the facts in that document. Now you would say that, okay, what is the difference then using a digital Aadhaar ID uh, and this one verifiable credential based Aadhaar ID? Is there any difference in that? Yes. So okay, I'll come to the why part here, but before that, this is going to be the flow. Uh, yeah. So user already have a DID. Now what user can do is, so for example, if user wants to use Aadhaar ID to to get a SIM card from a service provider, so what he will do is basically he will have an DID already. So he will first send some of the user data like his address, phone number, or whatnot, fingerprint or whatnot, whatever that issuer system needs. So for example, in this case, if it is Aadhaar system, then Aadhaar will verify all this information that it is anyway doing, and then issue this verifiable credential to the user. Okay. Now the verifiable credential has a proof. So if this is a verifiable credential, these are the subject of like what are the data that is going to contain, and then there is a proof that who has issued to you this document to you, like a signature kind of thing, and also who is the issuer. So here you can see the DID of that guy, like Aadhaar system who has issued this document. So he will send that all the like a document to the user, and now the user is able to use this document to get any SIM card or any kind of service from the service provider, as long as service provider trust that issuer. Okay. But the difference here is that the service provider need not to send the document to again the identity provider to verify it, because he has already attached the digital signature. Now, if the service provider has to verify the digital signature of issuer, all he has to do is query the blockchain, fetch the DID document of that issuer, and verify on its own. So this is a very important and strong point of verifiable credential, that independent verification. You don't need to connect to the issuer to verify a document. All you need is a signature, public key of that issuer, and that can be fetched from the blockchain. Now, the consequences of this is issuer, you can scale this issuer system a lot. Like it is, because most of the request comes from the for the verification part, right? Issuance is one time, but verification is happening exponentially. Every time a user uses a service, the request goes to the Aadhaar system, for example. So they have to verify, and uh, Aadhaar, I think, has a API for that. So imagine the number of requests that Aadhaar API is getting. that can be avoided by the service provider. So, what we have learned here is DID is an identifier, but your actual data related, all the facts related to you are kept in the form of a verifiable credential, and you link that DID with the verifiable credential. So when a verifiable credential is created, it has a part called ID. This ID is nothing but your DID. So basically, you link all of your data, like your real world data or physical world data, to this ID, and that ID you only control. So without DID, verifiable credential is useless. I hope that answers your questions. That how would you identify that real employee? Who is that particular employee?
Yeah, and how do you control that? Means you're saying that you can control. So how do you control that? How do you exert that control actually? Yeah.
Yeah. So this DID, like I said, the DID has a public key,
Yeah.
right? And corresponding private key. So private key always with the user, or in that case, employee. So employee is having storing that private key in his wallet or whatever device that he wants. And every time if he has to prove something about him, he'll just use that verifiable credential and sign the verifiable credential and send it to the service provider. Service provider can verify those credentials and fetch all the informations from there.
Okay.
uh, I will actually show you the demo of this, and you will be able to see that how exactly it is happening. Uh, okay, the why part. So every data in that verifiable credential is verifiable. In this case, for example, if this is an airline ticket, and so all of these data are verified. So as a service provider, just by merely verifying the signature of the issuer, I'm sure that all these data are correct because the hash got signed, and you know all this business, right, of credential of any digital signature. So because of that, you actually end up verifying all of the data. So every data part is verifiable. It is secure and tamper proof because has was signed, and the signature is attached with the document. Independent verification, I already talked. There is a concept of selective disclosure also with verifiable credentials. For example, if I am presenting this, imagine that this is a air ticket, and I'm presenting this air ticket to a security guard over there. All security guard wants to know that what is my uh, like whether this air ticket is valid for like am I traveling today or not. If he wants to just know that fact, I don't need to share all of this information, like which gate number I am going to catch the flight, what is my boarding time, all this. Not all the things he just want to know. I can only share just two piece of information, like what is the boarding time and what is my name, for example. So this is possible using selected disclosure of inside a verifiable list. You can share attributes literally, and still you can prove that uh, the facts. Then of course you can do zero knowledge proofs also. You don't want to share the entire age to prove that you are 18 plus. You don't want to share your bank balance to prove that you are a millionaire. so so all these things are possible. So basically what I'm trying to tell you with all this is that it gives you a lot of flexibility in terms of what can you do with this. Like there are a lot of various things that you can do with verifiable credentials.
And then probably this is one of the key contribution of this architectural evaluation is the verifying the facts without disclosing information, right? So this is the key thing which had happened technically, basically in terms of evaluation. If you look at where you can verify people without disclosing actual information of the people, you can verify a fact without actually disclosing information, and this will serve quite a great kind of a value to the age where privacy is becoming so important, critical for each and every discussion that we do basically.
Hmm. Yeah. What I like about this architecture, or this framework, is basically you are not changing the existing system.
Yeah.
Normally what happens when you bring a new thing, you're scared that hey, I have to bring a new thing and I have to like discard my existing system. Here it's that is not happening. All the actors are still same. You still have identity provider, you still have user, you still have service provider. So this stakeholders are not going to change. Only the execution flow is going to change, and which is for a good reason. Like you are solving a scalability problem, you are solving a security issues. Uh, so yeah, it's a great framework actually.
Yeah. I think you answer this question, but there's one question I'm seeing it here: ki how you are ensuring that you are issuing VC to an authenticated valid user, basically. Because at the end of the day, there are identity providers are the government providers or any other providers, basically, right?
Hmm.
So can you just reflect on this
Yeah,
question?
yeah. So uh, I want you to visualize something that when you got your Aadhaar card for the first time, when you went to the, I think there used to be a booth where we go and do give our all the fingerprints and everything. That's the starting point, right? So when we went there, what is the thing that he asked? He asked me in my case, he asked me, I think my 10th ka certificate, or and also some more details like. So look at that flow, that I have given him some document and he returned me some other document.
Hmm.
So uh, but imagine, like, how would I have got the first document in the first place, the document which I have given, like my 10th ka certificate, for because I have given an exam to get a document, and using that document I have been issued another document. So basically, what I'm trying to say is the DID will be linked to some verifiable credential. So for example, let's take the to make it simplify, let's take the example of a login. So
Hmm.
I will use my email address, and I will enter the email address and the password that I hold to, let's say, identity provider called Google. Now Google is able to verify the fact that I own this email address, so he will be giving me a verifiable credential, or let's call it as an email credential. So he will be giving me an email credential. Now I can use this email credential to log into any of the website and get another service, or get another. So for example, if I'm using this email credential in Make My Trip, now the Make My Trip is giving me another credential called air ticket credential, so that I can fly. Did I answer this question, or?
Yeah. I think you answered this well. So I'm going to now the next question, which is an interesting question, and this question is also probably triggering a lot of discussion about futility of Web3, and people are saying that ki, why you need to go for Web5. See, in centralized system, there is somebody out there who is taking a lot of effort, right? Means yeah, they not only provide you the all the services, but they also manage your identity well, basically.
Hmm.
Suppose you lose them, basically, right? In the question here is, if I lose identity in centralized system, I can contact them and disable my identity, basically.
Yeah.
So how do I disable when the DID of my disable the DID if my private key get leaked? Basically, is there a way for me to? So what I'm trying to say is, administration of identity. Somebody is in Web 2, may somebody is doing that, basically. Who
Hmm.
would do the administration part of the identity management here?
Actually, a very good question.
Yeah.
Let's take a step back. Cryptography is a very old technology, right? Why we
Yeah.
haven't, and we know that it's a very secure way to log into a system. But why we have not been able to use it so far? Why we have been still able? We know that every day we are using cryptography as in the form of a SSL. So why we have not? Because of technical advancement. We didn't have mobile phone. We didn't have this the way to manage our things. The knowledge was not there. So because of those technical advancement, and especially when blockchain came, everybody is now aware about something called wallet, and becoming easier and easier and easier. So people are now educated. So that is one way to answer the question, that people are getting educated and aware that they can handle their data by their own. But having said that, imagine that if you have to use this verifiable credential for all of the Indian citizens who are farmers and all these things,
Yeah. Yeah.
then in that case, what will happen, that there is a concept of cloud agent that these guys are talking about. I'm not advocating on that. So what cloud agent basically does is encrypt your data at the user end, and they give you and they keep the encrypted data in their the cloud where. But you still needs to uh, remember the password that you would have used to encrypt the data. Else you must have a fingerprint in the mobile, that fingerprint sensor is there, right? So at least you can use the fingerprint sensor to unlock the data which is kept on the cloud agent. So you just pull the data from the cloud, that is which is encrypted, so cloud agent cannot misuse it. You pull the data in your local device and decrypt it and use it.
Yeah. So I think we can move quickly to the demo. But while you go for demo, there's definitely one question which I want you to reflect on, because people may find it difficult, right? Which are the entire public key, private key.
Yes,
So
yes.
when it comes to common user, basically, how easy for them to use this, right?
Hmm. Uh, so we have been brainstorming on this, and we realized that the starting point cannot be that you start and go and create a private key or public key pair, at least for few years, unless
Yeah.
everybody is very aware. So you still start with the Google login itself. You start with the Google. They know the Google thing. I will show you in the demo also. They
Sure.
still you will start from where they all the things which already they know. And and, and if you look at the blockchain space, right, why only few people are using blockchain? Because it does not start from the place where I know things. It start from some new world, like you have to create a wallet, you have to download browser extensions. So all these things are sorry about the noise here. All these things are creating friction for user to onboard.
Yeah.
So you can still start with the Google, and behind the scene, once you verify with the Google or any kind of identity system, centralized identity system, you create that those key pairs behind the scene, and so that user don't even know get to know that what is happening. I'll show you in the demo that how that UX looks like actually.
Sure.
But I definitely agree that it's very hectic to manage private keys. So yes. Okay. Just last point I want to mention is a concept of verifiable presentation. So what happens that the credential is shared to you by the issued to you by an authority, and while presenting this credential to service provider, you don't just directly send it to the service provider. You create something called verifiable presentation. Now, what this verifiable presentation means is, it basically means that it contains a verifiable credential which has the proof of issuer, but you still need to prove that this document was actually given to you. So the user also signs it. So basically, there are two proofs which gets attached, and this whole document gets shared to the service provider. So service provider verifies both of the signatures, issuer's ka signature as well as the user's ka signature. There are multiple flavors of verifiable credential, but this is the simplest one. Uh, okay. So I guess use cases you can find anywhere. Like most of the any kind of documentation can be login is one of the best use case. We have a product login product where we are using that verifiable credential based login. And there are many use cases. Anything related to documentation, digital signing, you can use this. Couple of resources are here before I go into a demo. If you are very new, very new, I request you to go through the labs .hypersign.id. It's our website where you will find some document to onboard people on this SSI or self sovereign identity space. It's a very initial document, and then you definitely have specs that you would like to go through, DID specs, credential specs, and you can track our like work, or if you want to get involved, you can just see what we are doing in the in this space. Like this is a GitHub, everything is public. So yeah. Okay, let's jump into demo. I would request those who are on the laptop, I would request you can follow with me. So basically my objective is to help you create this DID and see yourself that what is going the difference is going to be. So, like I said, okay, there is a we are building a product called Hypersign. It's basically a blockchain network to manage decentralized identifier. These DIDs, because like I said, right, the DID has to be managed on a blockchain. So this is the blockchain that we are trying to build. It is in the testnet stage, so very early on that. So this is basically a UI of that blockchain which is running with couple of nodes. Okay, you can see the number of nodes which is being run, and we are kind of testing this DID thing with this network. And on this network you can see that the DIDs are being stored on the blockchain, and the proofs have been attached to it. and all sort of information about that document. One critical information which I wanted to share is that any service, uh, there is a concept of two-way authentication. Like when you access a service, the service always verifies you, right? But what if, how would I make sure that I am trying to access with the right service? So basically you can verify the service as well. So two-way authentication, you verify the service, service also verifies you. So
Yeah.
there is a concept of service part here in the DID document, where you can attach your, as a service provider, you can attach your service endpoint. So but then again, you have to use any centralized way, like you add the CNAME or whatever, somehow you prove the ownership of uh, this URL or the domain that you own, and that domain can be attached here. So imagine that this document belongs to a service which I am trying to access. So I would be, I can verify that yes, I am trying to access the right service or not. Probably this will stop phishing attack, or probably. So
So unless you take it to the normal use cases, right? So
mm,
then it will show us, because this is one of the key part, right? The
yeah,
kind of messages that we get and kind of the communication we get on the mail, on SMS, right? We
mm,
end up falling into that because there is no way for us to verify
yeah.
the provider or the sender, basically. Maybe this could be a way to solve that problem, basically.
Yes, but over there is one more problem. The problem over there is, I think, that not technical but social engineering problem, that even with this, right, you have to click a button to verify whether this email was correct or not. But what if you're not aware that you have to click a button? Like you're not very
Yeah, basically
right.
anything which requires user input, right? In case
Mm-hmm.
of this OTP, what is happening basically, because you are asking user to enter OTP, right? If
Mm-hmm.
there is explicit user action involved, it is prone to
Yes.
phishing action. It should be very transparent for user. If you ask
Yeah.
user to take an action, it will be definitely going for the phishing kind of attacks, basically.
Yeah. Yeah. Okay. So okay, let's go with the flow. I would request you to follow me.
Yeah.
So one of the use case that we are going to test it right now is the authentication. And what is the starting point? So imagine the use case is we want to log into a website. But before I do all that, I will have to create a DID for myself. Okay. So for that, there is a UI here. So if you go to the explorer.hypersign.id, you will see this tab, wallet. You click on that wallet, it'll come, this, like this UI will come. Okay. And here what I'm going to do is I'm going to click on this button, Google login, and behind the scene it will create a DID for me on the network. And then we will go and check in the network as well, that whether the DID has been created or not. And then the Google will, issue me a verifiable credential, which I can see in my wallet. So basically this flow, user has having a wallet, first creating a DID on the blockchain, then giving his email address and password to Google. The Google is notifying the server that, hey, this user is verified, and the server and our server, like the Hypersign server, will be issuing a verifiable credential. Point to note over here is this Hypersign server is acting as a proxy issuer. Actual issuer is Google, but this guy is acting as a proxy issuer. The second point to note is it is stateless, so there is no database. So even if you are using email address, so don't be afraid to use that, because we are not logging it. We don't have a database. The server code is also available. So if you trust on me that I am not logging, then I think you can use. But you can see the code. It's not, the database itself is not there. It's stateless, just binary running. And this guy is going to issue you a verifiable condition, which you will have in your wallet. So we will look at this flow, and then we will see that how I can use this credential to access a website. Okay. So let me click on this Google login thing. I will use this account. Now behind the scene, DID is being created. So here you will see the transactions on the network probably, or I'll just reload this maybe. I think it's still happening. It takes some time because of the interaction with the blockchain.
I mean, but that is one question I wanted to ask. So, Vishwas, and somebody asked that question as well. Blockchain, well, it looks like it's free. I mean, we also talked about it's not much costing, but there's a cost of executing the transaction, right? And
Mhm.
sometimes there are some gas fees, sometimes the time it takes, basically, because the time is definitely a big challenge there, basically.
Mm.
And then overall tax, it put on the way the processing happens there, basically.
Mhm.
So how do you, I mean, this schema, and some the question is basically, so we are saying this is free, but it's not that. So
Yeah.
how do we basically come with terms with that, basically? So at
Mm.
face of it may not be costly, but at the background, at underlying, people are saying that it's definitely costly to do transaction on blockchain.
Yes,
Uh,
yes.
time it takes, basically.
Yeah. So, good question actually. Uh, uh, First of all, it is not free. Uh, uh, I mean, this is a hindrance in blockchain. Like you need to have a some kind of gas that you want to pay for it. But uh, normally, the way I visualize this thing to be used in real world is that you start from the websites. So you would not know that there is a wallet or anything like that. So, for example, you just want to access a service, right? So what you would do is my internet fine? Yeah. So what you would do is, let's say you go to an application, okay, and you will start from here. Actually, you don't even know that there is some wallet or something like that. So you click on this button, saying that, hey, I want to log into this website. Okay. Now there is in the network that we are building, there is a concept of that somebody else can pay a transaction fees for you. So if I'm using this service can pay a transaction fees for me. So for a user like me, I don't have to have a token or any gas thing in my wallet. I can simply start the flow, and this guy, the service which I am going to access, they are going to pay fees for that.
Yeah, it's like a onboarding cost for them. It's like a
It's like an onboarding
cost
cost. Yes.
they pay to acquire the customer, basically, right?
Yes. By the way, I just noticed something breaks up here. So, some problem, I don't know, with the server. I'm sorry about that. Uh,
Yeah.
but you can you go to this app.fire dot or maybe just fire.id. So this is one of the product that this is one of the other product that we have where we are actually using it in production. So you can go to this fire.id, and here you can click on this create campaign, where you can just click on this login, click to login button, and I will simply delete my account just to show you the flow. Confirm. Actually the same thing, but here that network is not being used, some other thing is. So here, if I click on this my account, it goes and creates me a DID, and then it asks the now if I go, so here I am already logged in, so I'll just show you that wallet, that what happened over there. Okay, so you can see that in my profile I have got a DID here. Okay, and there is a verifiable credential which was issued from the server called Hypersign, let's say, and it has certain data. Okay, and it has issuer, it has what schema that you would have used, uh, what is the document, that the information that this document represent, and I use that document to basically log into this website. So you can see, if I go now, I click on authorize, so the information is being shared to this website in the form of a verifiable presentation, and you know this guy is getting the all the information and letting me access the site. So this is where we are using, like, this is a production application where we are using this concept and trying to kind of testing it. And I forcefully, like, convince my team to not use any other authentication system because I wanted to test this thing. It is definitely hampering our business a bit, but now I'm seeing that for the good reason, like, we have so many DIDs have been now created. And yeah, And sorry, this didn't work. I'm not sure what happened in the backend. So this was a test explorer which didn't work here. So s- okay, so that's all from my side now. uh, I'll stop sharing the screen, and probably if you have another some more questions I can take up.
So we had taken that question about the cost, right? And so if I had to really simplify this one, right? It's like
Mm.
you when you control your data and your identity means until now most of the players or service providers they used to provision us, right, on their systems and their application basically. Here in a way they are provisioning themselves to use our uh, identity and use our data basically. Is that analogy right in place?
uh, can you repeat that? I think I'm not sure if I get properly that
So
question.
I'm saying that so I'm owning my own
And
identity and data basically. So when any service provider comes in, so now until now what used to happen that okay, I will go, I will log in and they will provision me access basically.
yes,
So
yes,
here in a way I'm provisioning access to them to use
yes.
my data and use my information basically.
Yes. So here in that example which I have shown, right,
Yeah.
where I logged into that Fire website, so that credential was issued to me by the Google actually, not by the Fire company. So I
Yeah.
can now use the same credential to log into any of the other websites. So it is my identity, and Fire cannot revoke
Yeah.
that
So
identity.
with this, I think we are also ending of the session's time. I hope all the participants here basically they would have enjoyed the discussion here. And thank you, Vishwa, for coming here and really walking us through this concept. Basically, conceptually, and making us understand, and more importantly, also showcasing it. Thank you for joining us. Thank you all the participants here asking those very pertinent, important questions.
Yeah.
So with
Thank,
this, we would conclude by thanking Vishwa to be part of this session.
thank you, Vinayak. And I'm sorry about that glitch which happened during
Yeah.
the demo. I didn't
So
expect.
people can still, you can still look at all those links which I had shared on chat window here. So please go through that. Any question and any issue you find, you probably can reach out to the Hypermine team as well.
Yes, yes.